Biogeography. Distribution of animals and plants. O organism occurs in uniform numbers throughout the world. Rather, specific organisms are restricted to specific communities or groups of communities. Three aspects of the distribution of an organism are generally recognized: geographic range, or the specific extent of land or water area where the organism normally occurs; the geologic range, or the distribution in time, past and present; and the ecological distribution, or the major biotic communities, i.e., marine biome, freshwater biome and terrestrial biome, of which the organism is a member. Certain biologists have also made distinction between geographic distribution, horizontal or superficial distribution, and bathymetric distribution, vertical or altitudinal distribution. Bathymetric distribution includes the following three realms: I. Holobiotic, or vertical distribution of organisms in marine sea habitat; E. Limnobiotic, or vertical distribution of organisms in freshwater habitat; and E. Geobiotic, or altitudinal distribution of organisms on land. All the living organisms in a given region are termed the biota of that region. The animals of a given region are collectively termed the fauna, and the plants of a given region. There is geographical distribution of species of all organisms on this Earth. The flora, i.e., fauna plus flora equals biota. Here, a distinction can be made between the following two terms: flora and vegetation. Flora mainly refers to the botanical composition of a place, i.e., the names of different plant species, while vegetation means the totality of forms in which the emphasis is not on names of different plants but their life forms, number and coverage. The studies of the distribution of biota are collectively called biogeography; of animals only, zoogeography; and of plants only, plant geography or phytogeography. There are two major approaches to the study of biogeography or geographical ecology: Kende, 1974, I. Descriptive or static biogeography, which deals with the description of biota of different botanical and zoological areas of Earth, and E. Interpretive or dynamic biogeography, which describes the forces which have brought about plant and animal distribution. Descriptive phytogeography. With a descriptive approach of phytogeography, will be discussed the major plant communities, biomes, of the world, and different vegetational belts of the Earth constituted by these biomes together with characteristic climatic conditions of the area. 1. Major plant communities, biomes, of the world. As already discussed in sufficient details, major plant communities of the world are classified chiefly on the basis of the kinds of habitat and environmental conditions into the following chief types: plant communities. Pipe. Aquatic terrestrial biomes, TTT. Fresh marine estuarine tundra forest grassland desert. 2. Phytogeographical regions of world, or chief vegetational belts of the Earth. On the basis of climatic and geographical conditions, the Earth is usually divided into the following four broad vegetational belts. A. Arctic zone. This zone is divided into the following two types. 1. Arctic proper. This zone occurs around the North Pole and remains covered with ice throughout the year. This zone in fact is tundra biome, and its chief components of vegetation include some algae, annual flowering plants, mosses and lichens. 2. Subarctic. This is a less defined zone which extends from southern Arctic to the northern limits of temperate zone. This region is very cold, contains abundant bogs and have vegetation including small height trees, shrubs and herbs in the months of June and July. Ground vegetation often includes some pteridophytes, orchids, insectivorous plants, mosses and lichens. B. North temperate zone. This zone extends between 30 degrees north latitude and 55 degrees north latitude and includes following two major zones. 1. North temperate of the eastern zone. This zone is further subdivided into the following four zones: I. Western and Central Europe. This zone is demarcated in north by the subarctics and in south by Alps and British Islands. Its forests are dominated by several genuspermous tall trees such as pinus, picea and abies, and angiospermous trees such as oaks, maple and chestnuts. Ground vegetation comprises orchids, wild roses, buttercups, viola, salvia, dianthus, etc. At high altitudes of this zone, trees are replaced by grassy vegetation with some herbaceous flowering plants. E. Mediterranean. This zone extends between 30 degrees north and 40 degrees north latitudes, south of mountain ranges in Europe and in Asia around Mediterranean Sea, and is characterized by warm temperate type climate. Vegetation is chiefly composed of fruit trees, olives, nut trees, oranges, and also some foreign palms, cacti, acacias, etc. In the Asian region of Mediterranean as in Arab countries, rainfall is low, deserts are common and sparse vegetation include following species: Atriplex, alhagi, polygonum and Phoenix dactylifera. E. Northern Africa. This zone includes the northern parts of Morocco, Algeria, Libya and Egypt. It is characterized by scanty rainfall and sparse vegetation. In cooler areas, i.e., mountains, some conifers and broad-leaved oaks are common. In deserts, including some portion of Sahara Desert, some herbs, shrubs, woody acacias and succulent xerophytes occur. IV. Himalayas, Eastern Asia and Japan. Tibet, China and Japan have different type of vegetation. In China and Japan, conifers such as Cryptomeria, Chiadopitys, Cephalotaxis, Ginkgo biloba and cycas, and angiosperms such as rhododendrons, Cinnamomum camphora and begonia are common. The vegetation of Himalayas will be described later in this chapter. 2. North temperate of the Western Hemisphere. It includes the parts of United States and Canada lying mostly between north latitudes 30 degrees to 55 degrees. The eastern coastal regions of these countries in the temperate belt have some very characteristic plant species such as tropical fern, Shizia pusilla. The forest communities are composed of conifers and deciduous trees. On lower altitudes, some wild cherries, plums, roses and orchids are abundant. In the New England region, trees of Ulmus americana and Castanea dentata are abundant. Forests of conifers are common in southern parts and on western parts of Rocky Mountains of USA. In North California grows Sequoia sempervirens, the tallest tree of world. Ground vegetation is composed of Silicornia herbacea, Rumex maritima, Monotropa uniflora, Saxifraga, primula, etc. In the Colorado Desert of Arizona and southeastern California, there are several types of xerophytic plants. C. Tropical zone. This zone is divided into two subzones. A. Polytropic. It comprises Old World or Eastern Tropics and has the following two botanical regions. 1. Tropical Africa. This is a large-sized landmass of varied topography. It includes high altitudes and Sahara deserts which have little or no rainfall. In Africa, most remarkable plant is Welwitschia mirabilis. Eastern part of Central Africa has India-like vegetation of Borassus flabelliformis, Tamarindus indica, Ficus, Aspargus, Clematis, Phaseolus, Cassia fistula, Erythrina, Acacia, Albizia, Ziziphus, Bauhinia, etc. 2. Tropical Asia. It includes Arabia, Pakistan, India, Burma, Ceylon, Thailand, Indonesia, Philippines and islands of Cassia fistula Indian Sea. In Arabia, the rainfall is low and most of the desert species are found. Coffea arabica annative plant of Arabia. Ceylon is rich in species diversity and ferns are the chief components of its sparse natural vegetation. Malaya, Java and Sumatra are characterized by heavy rainfall and their vegetation comprises varied types of palms, some types of ferns, tall trees, lianas and insectivorous plants. Some important plants of Java are albizia, pterocarpus, tamarindus, bombax, cassia, dendrocalamus, etc. The common trees of Burma and Thailand are jackfruit, orange, mango, banana, betelnut, etc. B. Neotropics. It comprises Mexico and major part of South America. The low rainfall areas of Mexico are rich in xerophytes. At higher cooler altitudes there is a forest of conifers such as pinus, spruce, quercus and populus. On mountain peaks grasses are most common. In wet areas of Mexico, there are mosses, palms, bamboos, orchids, etc. In South America, there are extensive forests of flood-resistant trees such as Berthalicia excelsa, Maximiliana regia and also mangrove vegetation. There are also found many epiphytes. D. South Temperate Zone. This zone includes extreme southern region of Africa, Australia and New Zealand. In African area, the vegetation is chiefly made up of ferns and gymnosperms. On the hills conifers are present. Its lower wet regions contain salix and phragmites and dry regions have grasses such as andropogon and trees such as acacia. The vegetation of northern part of Australia is similar to that of Southeast Asia and includes trees of palms, nuts, eucalyptus, acacia and casuarina. Some petridophytes are also found in the ground vegetation. In the South Australia araucarias are common. New Zealand forests are mostly made up of conifers together with ferns, palms such as Rhopalostylus, many species from Metrosideros. New Zealand has richest bryophytic flora. 3. Phytogeography of India. Indian subcontinent lying between 8% and 37 degrees north, and 68 degrees and 97 degrees east has its own peculiar physiographic, climatic and biotic features. It is surrounded on its south, east and west by oceans and in the north by mountainous chains highest in the world. The subcontinent stretches out between tropical and subtropical belts. Its climate casuarina is chiefly modified by oceans and mountains. In the south and in the far east the climate is typically tropical, while it is temperate in the north, and highly arid in the northwest. The general climate of India is of monsoon type. Vegetation of India. The most important factors used in the classification of Indian vegetation are rainfall, temperature, edaphic factors, biotic influences and life forms. There are two most common types of plant formation in India, forest and grassland. A. Forest vegetation. Champion and Seth 1968 have recognized the following 16 major types of forests in India. L. Moist tropical forests. 1. Tropical wet evergreen forests. These forests occur on the western Ghats, Assam, Kachar, parts of Bengal, parts of Mysore and Andamans. These forests are climatic climax forests with very dense growth of tall trees more than 45 meters high. The shrubs, lianas, climbers and epiphytes are abundant, however, grasses and herbs are rare on the forest floor. The rainfall exceeds 250 centimeters in these regions. The characteristic flora of these forests include Dipterocarpus indica, Hopi, Artocarpus, Mangifera, Emblica, Michelia, Urbatemia, Lagerstremia, Ixora, etc. 2. Tropical moist semi-evergreen forests. These forests occur along western Ghats, in parts of Upper Assam and Orissa. The rainfall of these regions is usually high, above 200 centimeters per year. These forests consist of dense and tall 25 to 35 meters trees along with shrubs. In these forests, because deciduous species such as Terminalia, tetramels and Sharia grow intermixed with the evergreen species such as Artocarpus, Michelia and Eugenia, so they are called semi-evergreen forests. 3. Tropical moist deciduous forests. These forests are distributed in a narrow belt along the foot of the Himalayas, on the eastern side of western Ghats, Chota Nagpur and Khasi Hills. These forests have high rainfall 150 to 200 cm throughout the year except few very short dry periods. The trees are deciduous remaining leafless for 1 or 2 months. The most common species is Teak tectona grandis in the south and Sal Sharia robusta in the north. Other common species of these forests are Dalbergia, Cedrella, Salmolia, Albizia, Terminalia, Cordia, Bombusa, Melia, Dillenia, Eugenia, Dendrocalamus, etc. 4. Littoral and swamp forests. These forests comprise mostly evergreen species and occur along sea coasts in wet and marshy areas and also in deltas of larger rivers on eastern coast. In saline swamps, mangroves are chiefly composed of Rhizophora, Bruguiera, Cereops, Nipa, etc. Inless saline areas, Phoenix, Ipomoea, Phragmites, Casuarina, etc. are found. I. Dry tropical forests. 5. Tropical dry deciduous forest. These forests are distributed almost throughout the country except Kashmir, beyond Bengal, Rajasthan and western Ghats. These occur in areas with annual rainfall ranging from 75 centimeters to 125 centimeters and with a dry season of about 6 months. The trees are small 10 to 15 meters but canopy is open. Shrubs are abundant. These forests include following common plant species: Sharia robusta, in north Tectona grandis, in south Onogysis, Terminalia, Semicarpus, Carissa, Emblica, Acacia, Ziziphus, Dalbergia, Dendrocalamus, etc. 6. Tropical dry deciduous forests of southeast Deccan region. In some parts of Tamil Nadu and the Carnatic coasts evergreen forests of short 10 to 15 meters but dense trees are found though the annual rainfall is relatively small. There are no bamboos but grasses are abundant. The common flora of this region includes species of Memisilin, Maba, Pavida, Faronia, Ixora, Sterculia, etc. 7. Tropical thorn forests. These forests are distributed in areas with very low rainfall as in western Rajasthan, parts of southern Punjab, Bundelkhand, Gujarat, Maharashtra, Madhya Pradesh and Tamil Nadu. The trees are short 8 to 10 meters, sparsely distributed, mostly thorny. Shrubs are more common than trees. Plants remain leafless throughout the year. During rains, grasses and herbs become abundant. The common plants of these forests are Acacia nilotica, Euphorbia is a common plant, Prosopis spicigera, Capparis, Albizia, Ziziphus, Euphorbia, of tropical thorn forests. Calotropis, Maduka, Tephrosia, Crotalaria, etc. 3. Montane Mountainous Subtro pickle forests. 8. Subtropical broad-leaved hill forests. These forests are dense, have predominantly evergreen species, and occur in relatively moist areas as lower slopes of eastern Himalayas, Bengal, Assam and on hill ranges as Khasi, Nilgiri, Mahabaleshwar, etc. In the north occur Quercus, Castanopsis, Shima and some temperate species. In eastern Himalayas due to higher humidity, bamboos, many epiphytes including orchids and ferns become abundant. In the south common trees are Eugenia, Actinodaphne, Randia, Ficus, Populus, Canthium, Mangifera and climbers are Piper, Nedum, Smilax, etc. 9. Subtropical pine forests. In western Himalayas and Khasi Giantia hills of Assam, up to an altitude of 1875 meters, open forests composed mainly of pine species such as Pinus roxburghi and Picasia. 10. Subtropical dry evergreen forests. Lower elevations of Himalayas have xerophytic forests containing mainly thorny and small-leaved evergreen species. These areas are characterized by low rainfall and low temperature. The common species are Acacia modesta, Dodonia viscosa, Alia cuspidata, etc. IB. Montane temperate forests. These forests are found at 1800 to 3800 meters altitude in the Himalayas. 11. Montane wet temperate forests. These forests are found in eastern Himalayas with high rainfall and also in Nilgiris in the south. The forests in the south are evergreen and are known as sholas. The trees are 15 to 20 meters high with a dense growth forming closed canopy. Epiphytes are abundant. The common plant species of these forests are Rhododendron nilagurcum, hopi, Artocarpus hirsuta, salmolia, etc. In the north, the west temperate forests extend from eastern Nepal to Assam at an altitude of 1800 to 2900 meters. These forests are evergreen, dense and high, up to 25 meters. The common plant species include Quercus, Acer, Prunus, Ulmus, Begonia, Loranthus, etc. In the western Himalayas, Quercus species dominate all over. Conifers as Abies, Cedrus, Picea, etc., and broad-leaved species as Betula, Alnus, Ulmus, Acer, Populus, etc., are also widely distributed. 12. Himalayan moist temperate forests. Central and western Himalayas have the forests of conifers and oaks at an altitude of 1500 to 3000 meters. The trees are tall up to 45 meters, but undergrowth is thin and deciduous. These forests have plants such as cotonias, Tear, Berberis, Spirea, Quercus, Cedrus, Pinus, Picea, Abies, Suga, Cupressus, etc. 13. Himalayan dry temperate forests. These forests occur in a narrow belt in the western Himalayas, extending from parts of UP through Himachal Pradesh and Punjab to Kashmir. They are open, evergreen forests with scrub undergrowth. Oaks and conifers are dominant. Rhododendron is widely found in alpine and western drier areas. Pinus gerardiana and Quercus ilex forests, which occur throughout Himalayas, are common, while in the eastern moist zone Abies, Picea, Larix, Juniperus are found. Other associated plant species are Cedrus, Picea, Daphne, Artemisia, Fraxinus, Alnus, etc. V. Alpine faux rests. 14. Subalpine forests. These evergreen forests are open and occur throughout the Himalayas at high altitudes, above 3,000 meters up to tree line. They comprise mostly conifers such as Abies spectabilis, broad-leaved species such as Betula and rhododendron, and shrubs as cotoneaster, rosa, lonicera, smilax, etc. 15. Moist alpine scrub. Throughout the Himalayas, above the timber line up to the height of 5,500 meters, dwarf evergreen shrubby growth of conifers, juniperus, and broad-leaved species rhododendron are found. 16. Dry alpine scrub. In areas with low rainfall below 35 centimeters, open xerophytic scrubs such as juniperus, carragana, eurosia, salix, etc., are found up to 5,500 meters. B. Grassland vegetation. In India, natural grasslands, as climax formation, are not present but occur only during succession. The following three types of grasslands occur in India. 1. Xerophilous that occur in dry regions of northwest India under semi-desert conditions. 2. Mesophilous which are extensive grass flats or savannas and occur in moist deciduous forests of Uttar Pradesh. And 3. Hygrophilous which are called wet savannas. These three basic types of Indian grasslands have been further subdivided into the following 8 subtypes, each of which is named on its dominant species: Sahima, Dicanthium, Cenchrus, Phragmites, Saccharum, Bothriochloa, Symbopogon, Arundinella, Dioxia, Arundinella, and Dashampsia, Dioxia. 4. Floristic botanical regions, provinces of India. The Indian subcontinent is characterized with a variety of climate types, and the flora of the country is also correspondingly of different types in its different parts. The country has been divided into the following 9 floristic regions for the study of flora. A. Western Himalayas. It extends from Kumaon to Kashmir and has annual rainfall up to 200 centimeters. Altitudinally, there are following 3 zones of vegetation corresponding to 3 climatic belts. I. Submontane zone. This extends up to 1500 meters altitude and comprises mostly of Sawalik ranges. The forests are tropical and subtropical, having trees such as Sharia robusta, Dalbergia sisu, Cedrela tuna, Ficus glomerata, equals Eugenia hombolano, equals Acacia catechu, I.O. Butea monosperma, A.O. and R. Doc. Ziziphus N. 35 2 thorny succulent EU %. Forbias. DIWSL. Most common tree species are Abies, Betula, Juniperus, and rhododendrons. The herbs which occur near the snow line include species such as Primula, Potentilla, Polygonum, Geranium, Saxifraga, Aster, etc. Equals. Deccan. Closing square bracket. Dot dot. It includes regions of Sikkim and Nika and is characterized by more rainfall, less snow, and higher temperature. This is also divided into the following 3 zones altitudinally. A tropical zone. Up to 1800 meters altitudes. This zone has tropical semi-evergreen or moist deciduous forests. These forests comprise the plants such as Sharia robusta, Acacia catechu, Delbergia sisu, Terminalia, Albizia, Cedrela, Dendrocalamus bamboo, etc. B. Temperate zone. This zone extends between 1800 meters to 3800 meters altitudes and has typical montane temperate forests which are dominated by oaks such as Michelia, Quercus, Pyrus, Simplocos, Eugenia, etc. At lower levels and by conifers as Juniperus, Cryptomeria, Abies, Pinus, Larix and Suga, and also Salix, Rhododendron and Arundinaria bamboo at higher cooler levels. C. Alpine zone. Beyond the temperate zone extends alpine zone up to 5000 meters altitudes. It has alpine vegetation including Juniperus and rhododendron with its other typical flora. C. Indus plains. This zone includes the arid and semi-arid regions of Punjab, Rajasthan, Kutch, Part of Gujarat and Delhi. The rainfall is less than 70 centimeters. The vegetation is tropical thorn forest in semi-arid region and is typical desert in the arid region. The plants of this zone are primarily xerophytic. The common plant species of this zone are Acacia nilotica, Prosopis sp., Salvadora, Tecamella, Capparis, Tamarix, Ziziphus, Calotropis, Panicum, Saccharum, Cenchrus, Euphorbia, etc. D. Gangetic plains. This region extends over Uttar Pradesh, Bihar, Bengal and part of Orissa and is characterized by moderate amount of rainfall and most fertile, i.e., alluvial soils. Vegetation of this zone is chiefly of tropical moist and deciduous and dry deciduous forest type. The common plants Optis zone are Dalbergia sisu, Shesham, Acacia nelotica, Babul, Saccharum munja, Butea monosperma, Maduka indica, Mahua, Terminalia arjuna, Buchanania lanzan, Chironji, Diospyros melanoxylon, Tondu, Cordy mix of Lysera, Acacia catachu, Care, Azadiracta indica, Neem ficus bengalensis, Burgid, Ficus religiosa, Pipal, Mangifera indica, Mango, and weeds in Grissesicus xanthium, Cassia, Arjmun, Amaranthus, etc. In Gangetic Delta, South Bengal, mangrove vegetation is common. Central India. It comprises Madhya Pradesh, parts of Orissa and Gujarat. The rainfall is 150, 200 centimeters and its vegetation is thorny, mixed deciduous and teak type. The chief plants of this region are Tectona grandis, Maduka, Diospyros, Butea, Dalbergia, Terminalia, Carissa, Ziziphus, Acacia, Mangifera, etc. Malabar, West Coast. This region includes western coast of India from Gujarat to Cape Comorin and has heavy rainfall. The forests are tropical evergreen in west, semi-evergreen towards interior, subtropical or montane temperate evergreen forests in Nilgiris and mangroves near Bombay and Kerala coast. Deccan Plateau. This region extends all over peninsular India, i.e., Andhra Pradesh, Tamil Nadu and Karnataka, and has rainfall up to 100 centimeters. Its central hilly plateau has tropical dry deciduous forests of Boswellia serrata, Tectona grandis and Hardwickia pinnata, while the low eastern dry Coromandel coast has tropical dry evergreen forests of Santalum album, Chandan, Cedrela tuna and Planticus acacia, Prosopis, Euphorbia, Capparis, Philanthus, etc. Assam. This region is characterized by heavy rainfall 200 to 1000 cm. The vegetation is either dense evergreen forest or subtropical. The evergreen forests include trees such as Dipterocarpus macrocarpu, Meshua faria, Sharia robusta, Ficus elastica, etc. Bamboos as Bambusa pallida, Dendrocolomus miltoni, etc. Grasses such as Imperatus cylindrica, Saccharum sp, Themeta sp, insectivorous plants as Nepenthes sp, and also epiphytes, ferns and orchids. In the northern cooler regions, wet hill forests include plants such as alnus, betula, rhododendron, magnolia, etc. The hilly tracts also have pine forests of Pinus cassia and P. insularis. Andamans. This region possesses a varied type of vegetation, mangroves and beech forest at its coasts and evergreen forests of tall trees in the interior. Important plant species of this island are Rhizophora, Mimosaups, Calophyllum, Lagerstremia, etc. Patierns of distribution of biota. 1. Distribution. The plants and animals exhibit specific patterns of distribution over the globe, continuous distribution. A taxon distributed throughout the world in all climatic zones or in all the continents in at least one climatic zone is said to have continuous distribution. It is of the following types. A. Cosmopolitan distribution. Such a taxon or a species occurs in all climatic zones. The common plant species of nearly cosmopolitan distribution are Chenopodium album, Taraxchium officinale, Phragmites communis, Urtica dioica, Poa annua, etc. Among the animals the following species have cosmopolitan distribution: Tyto alba, Ardea cinerea, Falco perigenus, Vanessa cardui, Nonophylla and Macrobiotis huffalandi. B. Circumpolar distribution. Certain species such as Saxifraga oppositafolia, Carex laponica, Ranunculus nivalis, etc., are distributed in a belt around the North Pole. C. Circumboreal and circumaustral distribution. The species which are distributed in a near continuous belt in the temperate region of northern or southern hemisphere are said to have circumboreal and circumaustral distribution respectively. The genera Alnus, Draba, Acer, etc., are circumboreal in distribution and Danthonia is circumaustral in distribution. The species which are distributed in a near continuous belt in the temperate region of northern or southern hemisphere are said to have circumboreal and circumaustral distribution respectively. The genera Alnus, Draba, Acer, etc., are circumboreal in distribution and Danthonia is circumaustral in distribution. D. Pantropical distribution. Certain plant species as Bauhinia, Dalbergia, Dioscorea, Corchorus, Ocimum, Cassia, Eugenia, Philanthus, etc., are distributed throughout the tropical belt. E. Discontinuous distribution. A taxon distributed in two or more widely separated geographical areas is said to have discontinuous distribution. Such taxa may occur in several small in the same continent or in two different continents of the same or different hemispheres. For example, two plant species, Saxifraga and Selene, are distributed in Arctic region and high altitudes. Likewise, 3 genera of dipnoi fish, Epiceratotus, Protopterus and Lepidosiren, are distributed in Australia, Africa and South America. There are various other examples in plants and animals which show discontinuous distribution. Bauhinia is a common plant of tropical belt. 2. Endemism. Species which are spread over a wide area or in different ecological conditions are said to be cosmopolitan. Some of them, called endemics, are restricted in their distribution to a small region. This phenomenon of restricted distribution associated with some geographical or ecological factors is called endemism. Numerous plant families, genera and species are found to be highly endemic. In the Himalayas, some 28%, 3,169 dicot species, of all the dicots are endemic. Chatterjee, 1939. For example, a great proportion of the taxa of the flora of oceanic islands is endemic to those islands only. Some imported endemic plant genera of Indian deserts are Omania, Xerodia, Leptidenia, Denia, etc., and of India are Amphicombe, Didoceras, Dodecania, Alteria, Crudicea, Halandia, Legionandra, Zealandium, Hitchinia, Blephariostema, etc. Certain important examples of endemic Indian plant species include Ficus religiosa, Ficus bengalensis, Agel marmelos, Artocarpus nobilis, Crotalaria juncea, Datura metal, Indigo ferritinctoria, Aletaria, Eleusine coricana, Piper nigrum, Piper longum, Sesamum indicus, Hibiscus abelmoschus, Butea monosperma, Beaumontia grandiflora, Memisilum umbellitum, Holmeskeoldia sanguinea, Feronia elephantum, Sirocca indica, Sharia robusta and Caryota arens. Among endemics, some species exhibit very localized distribution and are called local endemics. Sometimes mutants appear and vanish without being able to compete with parental species, and are called pseudo-endemics. Some species may show a restricted distribution but cover large areas in course of time. This is called expanding or progressive endemics. Some old species may be restricted to a small region because of a severe decline in their population, a phenomenon called contracting or retrogressive endemics. Lastly, there are following two more types of endemics. 1. Paleoendemic or epibiotic or relics. These endemics are supposed to have been the remnants of a once widely distributed taxon in the past, e.g., Ginkgo biloba, Sequoia sempervirens, Trapanatans. These endemic taxa are supposed to have 3. Center of origin. IDIS maintained that for every species, there is one region from where it came into existence. Thus, some areas might have given rise to many species. These regions are, therefore, called the centers of origin. Plants evolved much earlier than man. Paleobotanical evidence helps us to arrive at conclusions on the center of origin. For example, evidently Syncana, tomato Lycopersicum esculentum, and tobacco Nicotiana tabacum, N. rustica originated in South America. Cotton Gossypium sp. and chili Capsicum sp. originated in Central America. Lychee chinensis T. camellia Arthea sinensis, and Brinjalt Solanum melangina originated in China. India is the center of origin of many crop plants such as rice, Oryza sativa, sugarcane, Saccharum officinarum, and Gram. Cicer arietinum. Descriptive zoogeography. A few groups of animals are cosmopolitan in having worldwide distribution, and most animals are restricted in distribution because of some kind of barrier or because of past history of origin and dispersal. An understanding of their present-day distribution takes us into zoogeography. Major units of distribution are the zoological region or zoogeographical regions, areas defined largely by the past and present relations of the continent to each other. Each region is further subdivided into faunal or ecological units, depending on the criteria used. Zoogeographical regions. There are 6 zoogeographical regions, each more or less embracing a major continental landmass, and all have long been separated from one another by water, oceans, and freshwater bodies, mountain ranges, or desert, so that each region has evolved its distinctive and characteristic orders and families of animals. These major distributional units were first recognized by Plater, 1858, modified by Huxley, 1868, extended by Wallace, 1876, and best described in a modern way by Darlington, 1957, and others. The 6 zoogeographical regions are the Palearctic, the Nearctic, the Neotropical, the Ethiopian, the Oriental, and the Australian. Because some zoogeographers consider the Neotropical and the Australian regions to be so different from the rest of the world, these two are often considered as regions or realms equal to the other 4 combined. They are classified as Neogea, the Neotropical, Notogea, the Australian, and Metagea, the Palearctic, Nearctic, Ethiopian, and Oriental. Moreover, 2 zoogeographic regions, namely the Palearctic and the Nearctic, are quite closely related, so the two often considered as one, the Helarctic. In fact, these 2 regions are similar in climate, vegetation, and in their faunal composition, having animals such as wolf, hare, moose called elk in North America, caribou, wolverine, and bison. A. Palearctic region. This largest region comprises the whole of Europe, Soviet Russia, northern China, Japan, northern Arabia, Persia, and narrow strip of coastal North Africa. It is subdivided into European, Mediterranean, Siberian, and Manchurian subregions. Its eastern parts have characteristic fauna of the following animal species: Rhacophorus flying frog, bombinator, fire-bellied frog, Agkistrodon hales, pit viper, Strix urulensis, Grus japonensis crane, X galericulata, Erinaceus hedgehog, Podsis panderi, Capricornus sumatransis, Camelus ferus camel, Bos mutus, Ailuropus great panda, Panthera tigris altica, tiger, Unchia unchia, Phoca sibirica, freshwater seal, Pteromes volans, Equus hemionus donkey, and Macaca fuscata, rhesus monkey. The common fauna of western Palearctic include animal species such as Clupea horrengus, herring, Sardina pilchartis, fish, Gadus morua, codfish, Vipera amidites, viper snake, chameleon, arboreal lizard, Pelecanus onocrotylus, pelecan, Fratercula arctica, Phonocopterus ruber, Rangifer tarandus, caribou, Ovis ammon, Dama, Capra egregris, Odobenusros maris, walrus, Ursus arctos, lynx, wildcat, castor fiber, beaver, Hystrix cristata, porcupine, and Panthera pardus, leopard. B. Nearctic region. This region comprises the North American continent south to the Tropic of Cancer, i.e., Greenland and North America. It is subdivided into Californian, Rocky Mountain, Alleghanian Canadian subregions. The Nearctic is the home of many reptiles and has more endemic family of soft vertebrates. Characteristic fauna of this region include animal species as Ambystoma tigrinum, Crotalus adamantius rattlesnake, Branta canadensis Canadian goose, Larus schisticigus gull, Bicephala alveola, Meleagris gallopavo turkey, Didelphis marsupialis, opossum, Obibos moschatus, muskox, Rangifer tarandus arcticus caribou, bison, North American bison, Odobenusros maris divergens, Cystiphora cristata, Martes penanti fisher, Lutra canadensis otter, Dasypus novemcinctus armadillo. Canis latrans, Procyon lotor, raccoon, Legionoriensis acutus, Delphinapterus lucas and Anhydrolutric. C. Neotropical region. It includes Central America, South America, part of Mexico and the West Indies. This region lacks well-developed ungulate fauna of the plains, but have rich, distinctive, varied endemic fauna of vertebrates. Characteristic animals of this region are Lepidosiren, lungfish Lepidosteus garpike, Histrio. Tortoises Dermatomes, Storotypus. Peltocephalus, Heloderma horridum. Iguana, Amazilia yucatanensis. Phonicopterus ruber, Pelicanus. Occidentalis, brown pelecan. Phylacrocorax hairy C, Sarcoramphus. Papa, amazonica, Spheniscus. Magellanichus, Chironex minimus. Desmodus rodentus, Myrmecophaga. Tridactyla, giant anteater, Tapirus. Terrestris tapir, Llama vicuña, Llama. Guanico, Panthera onca, Arctocephalus. The jaguar Panthera onca maintains the populations of many prey species at low levels, establishing a balance of nature in the neotropical forest. Australis, Cavia apria, Bradipus tridactylus, three-toed sloth vulture. Gryphus, Pterocnemia pennata and Aramacau. D. Ethiopian region. The Old World counterpart of the Neotropical is the Ethiopian, which includes the continent of Africa, south of the Atlas Mountain and Sahara Desert, southern Arabia, Madagascar and Mauritius. It embraces tropical forests in Central Africa and in the mountains of East Africa, savanna, grasslands and deserts. It includes a varied vertebrate fauna and several endemic families. The characteristic animals of this region are Protopterus, lungfish, Crocodylus niloticus, Sagittaria serpentarius, Struthio camelus, ostrich, Oryx gazella, African antelope, Giraffa camelopardalus, giraffe, Loxodonta africana, Africana elephant, Equus quagga, Hippopotamus amphibius, Daubentonia madagascariensis II, Lemur cata, Macaca sylvana, Pan troglodytes, chimpanzee, gorilla, Acinonyx jubatus, Panthera leo, lion, hyena, and Delphinus delphus. It lacks deer and bear among mammals and salamanders and tree frogs among amphibians and contains several endemic families of birds. E. Oriental region. It includes India, Indochina, South China, Malaya, and the western islands of the Malay archipelago. It is bounded on the north by the Himalayas and on the other sides by the Indian and Pacific Oceans. On the southeast corner, where the islands of the Malay archipelago stretch out toward Australia, there is no definite boundary, although Wallace's line is often used to separate Thierrental from the Australian regions. This line runs between the Philippines and the Moluccas in the north, then bends southwest between Borneo and the Celebes, then south between the islands of Bali and Lombok. A second line, Weber's line, has been drawn to the east of Wallace's line. It separates islands with a majority of oriental animals from those with a majority of Australian ones. Since the islands between these two lines form a transition between the Oriental and the Australian regions, some zoogeographers call the area Wallacea. Smith, 1977. The Oriental region is divided into the following four subregions: Indian subregion, Ceylonese subregion, Indo-Chinese subregion and Indo-Malayan subregion. Its characteristic fauna includes the following animal species: Rhacophorus perdalis, Gaviolus niloticus, Gharial, Calops versicolor, garden lizard, Draco volans, flying lizard, Draco dussumieri, flying lizard. Python reticulatus, Naya, Indian cobra, Ophiophagus hanna, Gallus, jungle fowl, Pavo cristatus, peacock, Milvus migrans, pariah kite, Eudynames, colt, Setacula cromeri, rose ring parakeet, bubo, great horned owl, Corycius bengalensis, blue jay, Dinopium bengalens, golden-backed woodpecker, Corvus splendens, crow, Argusianus argus. Elephas maximus, elephant, Rhinoceros unicornis, antelope cervicapra, black buck, axis, spotted deer, Bocelephus trichocamelus, blue bull, Selenarctos tibetans, black Himalayan bear, Melarsus ursinus, sloth bear, Sus cristatus, wild boar, Hystrix lucra, Indian porcupine, Purpus, mongoose, manus, pangolin, Soriculus, Indian shrew, Hyena striata, Panthera tigris, Panthera pardus, Babyrussa babyrussa, Macaca mulata, Presbytus entellus, Langor, Congo pygmaeus, Organgutan, Ilurus fulgens, and Hylobates lar given. F. Australian region. This region includes Australia, Tasmania, New Guinea, and a few smaller islands off the Malay archipelago. New Zealand and the Pacific Islands are excluded, for these are regarded as oceanic islands separate from the major faunal regions. Partly tropical and partly south temperate, the Australian region is noted for its lack of alien connection with other regions, the poverty of freshwater fish, amphibians and reptiles, the absence of placental mammals and dominance of marsupials. Included are the egg-laying mammals, monotremes, and the spiny anteaters. The characteristic fauna of this region includes following animal species: Neoceratodes fish, Chelman rostratus, Philopteryx equi, Ornithorhynchus anatinus platypus or duck mole, Zagoglossus bruini prochidna, Techyglossus aculetus echidna, spiny anteater, Macropus gigantus, kangaroo, Notorix typhlops, Macrotus legatus, Dromaeus novae hollandiae, Petaurus australis, Paradisea rubra, Pterodophora alberti and Phacolarctos cinereus koala. New Zealand has Varanus comodensis, Sphenodon punctatus, Apteryx oenihosti, kiwi, etc. Sometime, South Polar region called the Antarctic or Archinodic is also included in these major distributional units. Antarctic region has the following characteristic animal species: Balinoptera musculus, blue whale, Orcinus orcam, Megadips antipodes, Aptenidites patagonica, penguin. A forestary emperor penguin, Pygoscelis adelii, Diomedia exulans, albatross, Chianus alba, and Lobodon carcinophagus. Avayya. Adaptations. Aquatic adaptations, volant adaptations, and desert adaptations. Key idea of adaptation maintains that organisms, animals and plants, are structurally and functionally designed for meeting the needs of life in the habitats in which they live. Thus, adaptations include adjustments by which an organism accommodates itself to its environment. These may occur by natural selection. In this chapter, only following three types of adaptations of animals have been described: 1. Aquatic adaptations, 2. Volant adaptations, and 3. Desert adaptations. For other sort of adaptations of plants and animals, see chapter 3. Aquatic adaptations. Aquatic adaptations occur in those animals which live in water habitat, viz., fresh, brackish or seawater. They are called aquatic animals or hydrocoels. Based upon the phylogenetic history of the aquatic animals, following TWGO types of hydrocoels have been recognized. 1. Primary aquatic animals. The primarily aquatic animals are those in which the phylogenetic history is restricted to water as habitat. Therefore, all their adaptations are originally designed to meet the necessities of aquatic life. Generally, by pit viper has heat-sensitive pits between each eye and nostril. This enables them to pick up changes in temperature around them. Primarily aquatic forms. This meant the fishes, which have never had a terrestrial ancestry, but have evolved from more primitive aquatic progenitors. As a consequence, their adaptation to a dense watery medium is perfect and they do not suffer as those secondarily adapted to through their inability to breathe water. They are, therefore, the primitive gill-breathing vertebrates. Primary aquatic animals include protozoans, sponges, coelenterate, some annelids, mollusks and arthropods, echinoderms, and chordates such as cephalochordates, amphioxus, urochordates, herdmannia, doliolum, salpa, etc., cyclostomates, petramizone, myxine fishes, etc. 2. Secondary aquatic animals. These are those hydrocoels which have aerochord of terrestrial life in their phylogeny, i.e., they are descended from ancestors which led a life on land. Secondary aquatic animals are lung breathers, mainly amphibious vertebrates, which through stress of circumstances such as inhospitable lands, where food was scarce or severe competitions were forced to return once more to the water. Consequently, these animals show in their body structure the evidences which speak of their ancestry from land-living animals, e.g., pila, frog and other amphibians, swamp river turtles, nodosaurs, phytosaurs, crocodiles, birds such as ichthyornis, penguins, albatrosses, petrels, ducks, geese, etc., and mammals such as hippopotamus, otter, whales, porpoises, etc. A. Primary aquatic adaptations. 1. Body contour. The form of body depends upon the habits of life. The majority of fixed and partly sedentary forms have radially symmetrical body forms, e.g., sponges, cycon, euplectula, hyaloma, etc., hydra, obelia, aurelia, metridium, sea anemone, echinoderms such as holothria, echinus, astropecten or starfish. The active locomotor type have fusiform, spindle-shaped elongated and worm-like bodies. The spindle form is the characteristic of fishes and wavy, worm-like form is found in the suckers, oral arms, annelids, Nereus. The piscine body is designed for fast locomotion in water. There occurs a side-to-side compression of head, body and tail into a beautifully curved streamlined fish form. Head is subconical. There is no protuberance over the body, which would retard the swift passage of the animal through water. Further, since their relative weight is more on the upper half of the fish body, on account of the myotomes, a dead fish will float ventral side turned upwards. Tentacle. Regarding the body form of planktonic organisms, which float passively at or about the surface, some are globular, some have umbrella-shaped medusa. Some have umbrella-shaped medusa of Obelia, Aurelia, and some have barrel-like shaped tunicates such as Doliolum and Salpa. 2. Swimming organs. Some aquatic animals float passively and do not possess much power's lateral fin of movement, e.g., dinoflagellates, protozoa. The sucker medusae and most siphonophores move by alternative contraction and expansion of their subumbellar side. Organs for active swimming exist in figure 18.1. Loligo, squid. Arthropods, e.g., prawn or polemon, annelids. Dorsal muscles. Ventral ossiculum foliaceous, 4 outgrowth foliaceous. Outgrowth equals underscore. E.g., heteroneurous. Cephalopods, e.g., sepia, octopus and tilde loligo and vertebrates. For example, the parapodia of heteronereus fig 18.2 are well adapted for active swimming. Each parapodium has a flattened structure divided into the nodopodium and neuropodium bearing cirri and setae. The prawn has specially adapted abdominal appendages called pleopods andropods for equals dorsal cirrus notopodium or shaped 1 chatae neuropodium equals trademark ventral cirrus. Figure 18.2 parapodium of heteroneurous swimming. Invertebrates, the primary aquatic animals are the fishes. The fish swim by the help of fins and also by lateral undulations of the flexible body. The fins of fish are of two types, the median fins and paired fins. The median fins include dorsal fins, caudal fins and ventral fins. The paired fins are the pectorals and pelvics, figure 18.3. The caudal fin is the chief propeller. The dorsal and ventral fins help to keep body vertical and the pectoral and pelvic fins help in propulsion and in making changes in direction. 3. Respiration. The primary aquatic animals are able to respire inside the water, without the need to come up to the surface. The exchange of respiratory gases takes place between the blood of these animals and the water outside. There are two methods of aquatic breathing. 1. Through diffusion through general body surface, e.g., protozoans, coelenterate and planktonic larvae, and 2. With the help of special organs called branchiar gills, e.g., prawns, and other crustaceans, unio, pila and other mollusks, and many vertebrates, such as fishes, tadpole of frog and salamanders. Indeed, gills of fishes are most remarkable aquatic breathing organs, utilizing dissolved oxygen of water. 4. Air bladder. Advanced nostril eye. Scales dorsal fin laterally caudal fin. Pipe. Mouth. Opening square bracket pipe. Operculum pectoral fin pelvic fin anal fin tail. Figure 18.3. Labio rohita, a freshwater fish called carp or rohu of India. Bony fishes contain air bladder or swim bladder which serve as an accessory respiratory organ and hydrant organ. Air bladder is a hollow outgrowth of the alimentary canal and is filled with gas or air. 5. Lateral line sense organs. Fishes have lateral line systems extending all over the body. It contains neuromast organs which act as rheoreceptors, i.e., detect pressure changes in surrounding water. 6. Skin. Skin of fishes is rich in mucus glands and or is protected with scales. B. Secondary aquatic adaptations. 1. Streamlined body. The body shape is streamlined like primarily adapted forms. Neck constriction disappears and tail enlarges, e.g., ichthyosauria, extinct fish lizards, cetacea, whales, dolphins, and porpoises, sirenia, manatees and dugongs, pinnipedia, walrushes and seals. Frog also contains streamlined body. 2. Enlargement of size. Aquatic vertebrates tend to be larger in size because in these creatures energy, which in terrestrial form is exhausted in gravitational forces, is turned into growth. For example, largest sulfur bottom whale, Balinoptera musculus, is several times bigger than the largest elephant. Other example include giant sharks and squids. 3. Submergence. All secondary aquatic animals need to develop capacity of submergence since swimming below water surface demands such an adaptation. For example, in whales the ribs are strongly arched, the lungs are massive, the external nostrils communicate with the median, blowhole, which is closable. Certain adult aquatic insects too are able to increase their period of submergence by storing air inside the sublateral space, e.g., NEPA. 4. Shortening of neck. There occurs reduction of length and mobility of neck. In whales cervical vertebrae, which are 7 in number like other mammals, are fused to form a solid and compressed mass of bone. 5. Disappearance of excrescences. Paddle like the external ears, pinnae, which hinder in water locomotion tend to disappear, since they collect sound waves in air medium and are useless in aquatic forms. Thus, ears are reduced in amphibious mammals and are lost in whales, true seals and walruses. The nostrils, nares, move towards the apex of head as in whales. Ichthyosaurs, phytosaurs, etc. Nares are often capable of being closed, e.g., otter. Likewise, eyes become water adapted by shifting higher on the faces in hippopaddle-like. Patamus, forelimb. 6. Occurrence of locomotory figure 18.4. Marine turtle hawksbill, Chelone imbricata. Paddles, fins. There occur fleshy and fin-like expansions of the body wall in whales and ichthyosaurs which help in propulsion. These fins may be dorsal or caudal. Dorsal fin is present in killer whale, while absent in Delphinopterus and Balaena. Caudal fin, also called caudal or tail fluke, of marine mammals in horizontal, vertical in reptiles, and the bone divides the tail into 2 equal parts rather than running into one lobe. In turtles, propulsion occurs by fin-like limbs, figure 18.4, but in whales, sirenians, etc., tail propulsion takes place as their hind limbs become disappeared. Pectoral paddles of whales and sirenians exhibit the following adaptations. 1. The restriction of movements corresponding to the elbow and wrist joints. 2. The fusion between digits. 3. Increase in the number of phalanges, called hyperphalangy, and 4. Increase in the number of digits for increase of expansive paddling surface, called hyperdactyly. In Nepa insecta, legs are flattened and oar-like. 7. Disappearance of hairs, skin glands, etc. In whales and sirenians, the skin becomes naked due to loss of hairs. The hair loss is compensated by the formation of a fatty layer below the skin, blubber, for the retention of the bodily heat. The blubber also has a hydrostatic advantage, e.g., it helps in flotation or to keep positions in the water and act in combination with the buoyancy of the aquatic. Triangular. Dorsal fin. L caudal. I firm. By. D. Quote. I underscore underscore. L underscore L underscore underscore. Underscore L. U equals ITE. Medium. Sweeter oil glands disappear as they have nothing to do with the aquatic mode of life. Muscles and nerves also atrophy from the integument due to its thickening and immobility. 8. Mouth armament. Since jaws are not used for mastication in whales, they lost the power of movement. Teeth become simplified. Homodont in dolphins. And greater in number. In sperm whale, teeth are present only on one jaw or entirely absent from both the jaws, e.g., baleen whale. 9. Skull modification. In certain aquatic mammals, e.g., dolphins, porpoises, the cranium is shortened and front part of the skull becomes elongated to acquire the shape of a rostrum. In the skull of the cetacea, the zygomatic arch is reduced to a vestige. 10. Simplification of vertebrae. In secondarily aquatic forms, vertebrates, the vertebrae tend to be simple. In ichthyosaurs, vertebrae are simple with biconcave center like the fishes. Various secondary articulations or zygapophysis become reduced, as body weight is supported by water. The chest too becomes cylindrical. The rib articulations are modified and are central, i.e., they are articulated to the centrum and are not articulated to the transverse processes. Sacrum in cetaceans and sirenians is more or less reduced, since it does not withstand and transmit the supporting impact of the hind limbs, as does in terrestrial forms. 11. Lightness of bones. The bones in aquatic forms are light and spongy. In whales, their interstices are filled with oil. Paddle-like forelimb. Figure 18.5. Killer whale Orcinus. VOIANT adaptations. The volant adaptations are concerned with the flight. The flight is a form of locomotion in the air under which the body has to be firstly prevented from falling down and secondly moved forwards, the speedier the better. Thus, volant adaptations must include modifications in the animal's body for reducing the weight of the body and also for the formation of organs capable of executing the flight. The flight may be of following 2 types. 1. Passive or gliding type flight. This type of movement involves no propulsion other than the initial force of jumping. Gliding is characterized by leaping or jumping from a high point and held up by some sustaining organs, then to glide to lower level. Thus, there is no locomotive force other than gravity. Here the wings are made of patagia which do not flap, i.e., do not move up and down by the muscular action. The gliding flights are performed by various lizards, e.g., Dracovolans or flying dragon, figure 18.6 fishes, e.g., Exocetus, figure 18.7 birds, e.g., ostriches, etc., mammals such as flying phalangers, Petaurus sirens, a marsupial, figure 18.8 flying squirrel, figure 18.8, etc., and amphibians, e.g., Rhacophorus, figure 18.8. All these forms are found to possess the following adaptations for the gliding. I. Development of patagia. The sustaining surface, wing, for the gliding is a fold or series of folds of skin, called patagium. The patagium lies between forelimbs and hind limbs and can be folded like a fan against the body when is not in use. In Draco, the patagium is supported by ribs, figure 18.6. Tychozoon, figure 18.8, is another gliding lizard which is commonly known as the flying or fringed gecko, and in which lateral expansion of skin patagium extends along the side of neck, body, tail and limbs in between toes. Flying underscore. Snakes, e.g., Chrysopelia, leap by the concave ventral side of body. The extinct reptiles pteroid e nostril, C. deli ag with SD. I. Head. Equals forelimb patagium ribs. Equals back. Hind limb. Claws. Figure 18.6. Dracovolans. Dactyls, figure 18.8, of Mesozoic era were volant. Creatures akin to birds, containing true flight patagia. Their patagia were extensions between limbs supported by ribs. Pectoral fin. Head. Eye. Nostril. Caudal fin. Dorsal fin. N. Mouth. Operculum. N. Anal fin, pelvic fin, lateral line tail. Figure 18.7. Exocetus. Second, third and fifth digits. The first digit remains free. Among mammals, flying squirrel, Siropterus, figure 18.9, has highly developed patagium. Its wide hairy tail is further supplemented by the hairy fringe on the patagium and along the rear of the thighs. In flying lemur Galeopithecus volans, Fig. 18.9, the patagium extends from side of the neck to the tip of the tail even including digits, which are also webbed. In the bats, the patagium is supported mainly by the elongated forelimbs and the traces of patagia are also found in front and behind the arms forelimbs in birds which have adequate supporting function. Flying frog too contains rudiments of patagia in front and behind the limbs. Eye enlargement and high insertion of pectoral fins. In flying fishes Exocetus are trim-billed creatures with large parachute-like pectoral fins which are highly inserted on the body. The pelvic fins are much smaller in size. The lower lobe of tail is also invariably longer, helping in leaping. The pectoral eye equals U hairy tail B equals a Chiropterus Galeopithecus volans, flying squirrel, flying lemur Petaurus, flying phalanger. Snout. Nostril adhesive pads. Eye or discs. Web. Forelimb. Tympanum. Hind limb. Trunk. Web. Equals otteral expansion of skin. C. Rhacophorus tychozoon, flying frog, flying gecko, patagium. Equals ong tall. E. Pterodactyl. Figure 18.8. Patagia of various animals. Fins do vibrate. Exocetus can fly up to 200 to 300 meters to escape from the large fishes such as tunny and albacore. Other genera of flying fishes are Dactylopterus, Pantodon and Pegasus. Pegasus is a little marine fish found along the coasts of Japan, China, India and Australia. They skim along the surface of the water for 40 feet or more. E. Webbing of feet. In flying frog Rhacophorus paradalis, figure 18.10, the feet are webbed which sustain the prolonged leaps. Flying frog's digits terminate in adhesive pads which help in adhesion to trees. 2. Active or true flight. It is the aerial flight caused by the action of wings. True flight is found in insects, pterodactyls, birds and bats. In all of them the nature of development and structure of wings are quite different and their analogy suggests that the flight has evolved independently in different groups. In true flights the power is implied and the movement in air is sustained. Varieties of wings. 1. Insect wings. The flying insects develop wings at their last molt. The mode of origin of the wing of the insects is different in the Exopterygoda and Endopterygoda. The wings are made up of cuticle and are strengthened by thickenings, called veins. The insect flight is affected by the flapping movements of the wings. Typically, there are two pairs of wings developed on the dorsolateral sides of the meso and metathoracic segments, e.g., Orthoptera, Isoptera, Coleoptera, Ephemeroptera, etc. In Diptera only the mesothoracic wings are developed. The wing muscles are highly striated and are rich in mitochondria. In fact, insect's body is ideally suited for the evolution of aerostatic adaptations because of the system of tracheae, which contain air and propodigium. Penetrate to the different parts of body. The highest degree of adaptation is met within the dragonflies, mayflies and damselflies. In mayflies, the adults are short-lived and has its alimentary canal filled with air. In the honeybees, there are air sacs associated with the tracheal system. These function in reducing the weight of the body. 2. Bat wing. In a bat wing, humerus bone ice well developed. Radius is long and curved and ulna is vestigial. B. Patagium. Or femoral. Hallux thumb isfriant, membrane. Clawed for crawling and climbing. In smaller in. Sectivorous bats figure 18.9. A. Pteropus frugivorus, Megateroptera. B. Vespertilia. Microptera, figure 18.9, Noctila insectivorous, Micropteroptera. The second finger is not free from third, but is attached toitdistally. These two support the anterior margin of the wing. The fourth and fifth digits are well developed. In frugivorous bats Megateroptera, figure 18.9, the second digit is clawed and free from the third. 3. Pterodactyl wing. In pterodactyl's wings, the radius and ulna bones are nearly equal. The next segment consists of a heavy fourth metacarpal bearing great wing finger and 3 small metacarpals supporting the first, second and third clawed digits. There is also present a pteroid bone which is directed towards the shoulder and supposed to support the anterior margin of a propodigium which lies in front of arm from the wrist to the neck. The single wing finger, i.e., fourth, is huge and forms the entire anterior support of the patagium beyond the wrist. 4. Bird wing. In birds forelimbs are modified into flight structures, the wings. The wings of birds are more specialized of all modern wings. In a wing of bird, digits are reduced to 3 and these are fused together to help in flight. The metacarpals are 3 which are unequally developed and co-ossified. The digits are represented by 1 or 2 phalanges which support the so-called bastard quills, i.e., 3, 4 or 5 feathers on the first digit, homologous of the thumb, of a bird's wings, figure 18.10. Volant adaptations of birds. Bird flight is characterized by the flapping of the wings. In flying, the bird lifts its body and drives forward by beating its wings in a characteristic way. An object moves swiftly in the air is affected by 2 forces. 1. Upward pushing lifting, and 2. Downward pull drag due to the action of gravity. Hence, for successful flight, enough force must be applied to neutralize the drag and also to move forward. Birds' wings are slightly concave, so are able to produce the air current for producing the lifting force. Birds have the following adaptations for true flight. 1. Body contour. The streamlined body is spindle-shaped or boat-shaped, encountering least aerial resistance and can easily be passed through the air. Thus, the beak is pointed, head is compact, neck is long and mobile and wings are attached high upon the thorax. 2. Development of feathers. The entire body of birds is invested with a close covering of feathers, constituting the plumage. The feathers form the exoskeleton of birds. These natures, masterpieces, are light, elastic, waterproof and most important in flight. Birds. Feathers are classified into quill feathers, contour feathers, down feathers and phyloplumes. Quills are flight feathers of wings are called remiges and those of tail are called rectrices. Structurally, flight feather consists of a basal quill or calamus and distal rotches or shaft. The rotches bears a leaf-like vein or vexillum, consisting of series of lateral barbs. Barbs consist of double row of barbules connected with each other by barbicles or hooklets. Through interlocking arrangement, the barbules end figure 18.10. Wing of pheasant, showing the 2 bastard quills. Barbicles form a sort of net which, after lull, 1957. Help in flight. 3. Presence of wings. In birds the forelimbs are modified into wings helping in flying. The hind limbs or legs are large and variously adapted for walking, running, scratching, perching, food capturing, swimming. 4. Pneumatization of bones. The bones of birds are hollow and air-filled. They also contain many carpometacarpus radius ulna. Wing feathers. Air cavities. These add buoyancy during flight. 5. Occurrence of flight muscles and keeled sternum. In birds, specific flight muscles are developed which connect the wings with limb bones. Each wing is depressed or lowered by an enormous muscle called pectoralis major. It is elevated or raised by pectoralis minor, the tendon of which is inserted on the head of humerus. The sternum or breastbone is well developed and bears a median keel or carina for the attachment of pectoralis muscles. 6. Development of air sacs. They act as air reservoir during respiration and serve as balloons to provide lightness and buoyancy to the body. Air sacs also help in internal perspiration, thus helping in the regulation of body temperature. 7. Brain and sense organ specificity. Cerebrum is well developed for controlling maneuverability, and optic lobes become enlarged for controlling the great development of sight, and olfactory lobes are reduced, i.e., power of smell is reduced. Birds' eyes are large and bear characteristic sclerotic plates, toricis, variable air pressure. Eyes also contain pectins, which are cone-like, vascular and pigmented structures to regulate fluid pressure within the eye, i.e., accommodation. 8. Beak. The conversion of forelimbs into wings is compensated by the presence of a bill or beak. The beak is horny and lacks teeth. 9. Mobile neck. The neck of birds is very long and flexible. 10. Single ovary. Presence of a single functional ovary of the left side in the female bird also leads to reduction of weight, which is very essential for flight. 11. Absence of urinary bladder. Birds do not have urinary bladder, which ice present to store the urine temporarily in. Other animals. Further, birds excreta semisolid excreta which chiefly contains the insoluble uric acid and urates. Urcotelic excretion. These features help in reducing the weight of body. Esophagus. Desert adaptations. Trachea. Eye, beer. Crop _ wing. Desert animals or xerocoles have proventriculus. Adaptations for following 3 sorts. 1. Moisture getting. 2. Moisture consort batty. On and 3. Self-defense agi. NST fizzy. Syrinx gizzard cal and organi. C. Envy. Ronment. Air sac heart 1. Moi. Toure getty. Ing. As already lung pancreas. Described in chapter 3. The securing of kidney. Adequate quantity of moisture as the prime need of desert forms and its scarcity as the beak eye. Ovary. Characteristic of the desert. At certain places of desert is found deep groundwater. Even then the surface sand is dry and burning. Hence, forgetting the deep water, rainwater from the superficial layers of sand, absorption of dew water, the xerophytic plants e.g., date palm and xerocoles e.g., moloch have varied adaptations. The date palm has long, deep exploring and horizontally spreading roots. The sand lizard or moloch has hygroscopic skin to absorb water like the ureter. Weaklaw. Intestine oviduct. Cloaca. Figure 18 to 11. Various volant adaptations of a female bird. Blotting paper. Its surface is covered with thorn-like scales. Figure 18.12. A few animals absorb dewdrops along with vegetation food. Barrel cactus affords drinkable water to thirsty desert people. Deezer rabbit, tortoises and wood rat Neotoma eat succulent plant for their water need. Jerboas, kangaroo rat Dipodomys pocket. Mouse Paragnathus and certain other rodents eat dry seeds and vegetation and quench their thirst. Carnivorous animals feed on their prey for food and water. Grasshopper miss of western North America. And long-eared hedgehog of Sahara. Desert eat insects and small rodents. For getting water. 2. Moisture conservation. After getting moisture it becomes essential for the xerocoles to conserve it. As a result, desert animals contain the following types of adaptations for the water conservation. Camel exhibits many adaptations for water conservation. For details see chapter 3. Eat to avoid water loss through skin. The horned toad Phrynosoma has hard and rough skin and moloch has scales and spines all over the body surface, i.e., skin. Eat Euromastix desert lizard, store water in large intestine. IV desert mammals has thick skin to avoid water loss by perspiration. In them the number of sweat glands in the skin are reduced or totally absent. Beet desert insects are wax-proof. Beet to conserve water. Desert animals remain in burrows during the daytime and come outside during night when the percentage of moisture in their burrow and outside is equal. Certain animals plug the mouth of their burrows during daytime. 3. Self-defense against scorching sun. The desert animals protect themselves from the extreme heat of the sand and arid climate by the following type of adaptations. Trunk. Head spines. Eye. Nostril. Mouth. Clawed digits forelimb. Horned toad Phrynosoma has hard and rough skin to avoid water loss. Eye. In burrow-digging species of reptiles, the nostrils are directed upward instead of forward. In most snakes nostrils are either reduced to pinholes or protected by complicated valves. Eat. The eyes of Typhlops, a burrowing desert snake, are overhung by the sheath. In ostrich and camel, the eyes are protected by reflecting heat of the sand by possessing a long neck. Eat. In lizard Mabuya, the lower lip becomes enlarged with a transparent window in it. IV. The ear opening of desert animals is either small or protected by fringes or scales or they may be abolished. Feet. Possession of venom is another desert adaptation, self-defense. Almost all desert snakes are poisonous. All poisonous spiders are also found in desert. Scorpions too are common in deserts. Feet. Gazelle antelope resembles the general coloring of landscape, white on sand, dark gray on volcanic rocks. It provides a good example of self-defense. 2 UIAVARYO 08 and BTA. 1. Write an account of primary aquatic adaptation. 2. What is adaptation? Give an account of volant adaptation. 3. Give an account of desert adaptations.